Okay, we can get started. Again, I'm going to try. This is a little new for me to do this in hybrid. So the last 2 years I taught this course. It's all been on Zoom. 2 years before that, I was always in class. So this is hybrid. So forgive me if I get lost, walk away from the computer. Remind me the microphone's here. Another thing, if you see, I'm going to try recording everything. We'll put it up on our videos YouTube page. If you see that I'm not recording, please remind me. I often forget. Just remind me. I'll just take you here. This is our YouTube page. And in here, we have all our courses really have already been run before. I'll add our introduction for last year. If you want to get help.
Google Fi.
So
Phone plan by Google. Save big on Samsung Galaxy A series.
I'm not making money from these adverts. This is Matt. So Matt's in my team and he runs the training more generally. So some training during the year will be emails from Matt. If you ever want to join the training, please email me as well. And I can make sure you get on it. But here we have systems, hopefully for you to get help outside of class as well. And it will be explained in the videos there, but I'm going to show you as we go along. So most of the useful stuff which we will be following through is in this session, this big table here. Sharing screen, yep. And we can see the actual first section we're going to run through today is our introduction to R. This course is a very practical course. So I'm going to teach you really how to analyze high throughput sequencing data and some other data types. Yes. Okay. What I can do is I'm recording it. I'm not really sure what to do. I never got sent this Zoom link. It was a little hard for me to follow that up. What I'll do is I'll get us started. I'll get to the installing R, and then I can try and chase down some of these Zoom things. Sorry about that. Already hybrid. So, we'll be working through from intro to R, plotting an R, all the way through down to single cell RNA-seq analysis. You should learn this all. Really, everything you need to know to do high throughput sequencing analysis is going to be covered at some point in this course. And we're going to be starting today, the next few sessions, in our introduction to R. Okay. So just to tell you a little bit about the pages, so we can be oriented in the course. Every one of these little sessions we're going to do looks exactly the same or have the same setup. You have links to the slides here, so you can have slides or single page. I'm going to show them again in a second. We have exercises. I encourage you to do these, and the exercise deliberately framed so that they teach that little bit extra you kind of need to know. But we have the exercises and we have the solutions for everything as we go along. Another useful thing we have on this page is our Twitter link, so follow us on Twitter, but this getting help. So if you're not in class, you're lost a little bit and you want help right there and then, sometime in the week, rather than necessarily straight away email me, come to the getting help page. And you can see here, we will keep them open. We will mark them as resolved. But here we have all the questions from people previously. And you can actually go and look to see if they're your problem. Here's Matt, who's answering this question for someone. He's actually asked the question too. Well, this is quite a common problem. People have problems with Rio. This is a package we're going to use. And if you had the problem, you'll see that someone's already posted a solution. If you have your new question, something which you haven't found there, but you want to raise it, just do new issue, give it a title, and then just leave your question. Now, once that's there, me and my team get an alert, and it will pop here. It is public, so that is obviously If you ask something, people will be able to see it, but that's often useful because the questions you're asking aren't typically that stupid, and other people are thinking the same problem. So it's nice that we solve it here in one place. Okay, so this page is tested every time we update it, so we know it works, we know it's going to work in your hands, the course. We give a little description, and again, if you want to download the material to have on your own computer, which a lot of you may want to do, just click here, we'll download it. I've already got a copy somewhere, and inside there, I'm going to show you again the course, but there's a little section called Our Course. If I open that page, you'll see you have the same page I've got on the website, and you have all the slides and everything you need to take this course offline. Here we have the slides, so we have the embedded in the page. We have the actual slides, and this is how I'm going to talk through them like this. But one thing which got pointed out to us in the first year, slides are very hard to search. Control F if you want to search through a particular function or a particular thing. So we give you a single page version, and that is a lot easier to search. Every course is going to look the same deliberately, so it should be easy enough to follow through. So move this out of the way a bit. So in our first session today, we're going to get started with R. Like I said, this is a new experience for me, a little bit of hybrid. I'm going to try and stay near my laptop. We will have in future sessions, and sadly he's being called away to an emergency appointment today, we will have a TA, and that's David Rakina. So he did this in his first year 5 years ago, and he does bioinformatics every day. So he's going to be here helping out in future sessions. We just couldn't make it today. So we're on session 1. Follow along however you want, slide, single page. I speak quite fast. If it's going too fast, let me know, I will slow down. I also tend to mumble, the mask doesn't help. I will try and speak up. So today we're going to talk first off about the setup. So we're going to need to install R, we're going to have to look at RStudio, and this is the programming language we're going to use, and kind of the framework we will work with it. Talk a little bit about the background to R, data types in R, and reading and writing in R. Sorry, before I continue, just to say, so this is all on Zoom. Hopefully I will sort this out in the break. So if you aren't able to attend this session, it doesn't bother me if you want to join on Zoom, if you can't make it here physically. They don't need to communicate this with me, just join on Zoom. We will have that session set up better. So the first thing I want to look at is setup. As I just said, you can download all the material. I just showed you the link, and then you will have it all on your computer. And then inside there, I just showed this again, we should have a folder called presentations, slides, that's all your slides, single page, and then the actual R code. So the code which goes along with the sessions. And then we have our practicals as HTML pages, and then we have the answers. So those are all in that download file. Just did. I'll look again. First again, we have R course, presentations, slide, single page R. We have the exercises. And then later on, when we want to run these exercises, we also actually have the data we need there as well. Before I'm running any code in the practicals, and this is just a reminder, I'm going to show you how to do this when we open it up. You're going to want to set your R directory, so the place where R believes it's based, where it's going to work from, to the directory we just downloaded in R. So just to show you again, that's inside when we download this, there's that folder, and that's kind of where the whole course is based. And it has that data directory with all the files we may need to read in later on for exercises. So what is R? I'm not sure if, has anyone got any experience with R here? Has anyone done any work in R? Nope. Great. So we're starting from scratch. So R, has anyone done Python here? Great. A little bit of Python. Great. So, I deliberately write R as a scripting language. And it's not because I'm picking on R or anything, but most of these times we would say a programming language. R isn't a super fast language. Okay, it's designed really for high-level data analysis, but I can tell you that's what you will be doing most of the time in your own work. So I kind of make this distinction between programming and scripting, but for you, it doesn't matter. It is Turing complete. You can do anything you want to do in R. It just may take a little longer. For some things in R are a little slow, but it is exceptional for statistical computing. So R, I think we just got someone in our waiting room. Is that the right person? So someone just joined. I'm hoping that's the person. Great. Whoever, set that person to tell them where to go. So R, being called R, was actually developed by Robert Gentleman, who we had at Rockefeller a few years ago for a talk. And Ross Harker, they took the R's and made R. But it's all based on this other language, S, which was developed by Bell Labs. That was proprietary, so Bell Labs owned it. So Ross Harker and Robert Gentleman, being open source minded, decided they were going to rewrite the language, call it R, and make it available for free. So you didn't have to buy hundreds of dollars worth of software off Bell Labs to start doing this. The really great things about R isn't just that it's open source and cross-platform. A lot of people come to R for its graphics capabilities. So you can make some very nice plots very easily in R. And that's our second session. We will show you some really cool ways to make plots. It has an incredible range of add-on packages. Oh, everyone's coming. Incredible range of add-on packages, and that means these are libraries, sets of functionality which other people have written. So if you're doing a particular type of analysis, you don't need to start from scratch. Often someone else has written the functionality. Active community of developers, so people are committed to making R better and writing the packages we need. So often new biological techniques come out, you will quickly find a package in R available for you to deal with it. And what I really, really love about R compared to lots of other languages is it has built into it thorough documentation. You can't make an R package without explaining exactly how it works, which is really important because lots of languages you can have these excellent tools, but you just don't understand quite how they work or how to use them. So like I said, R comes with excellent out-of-the-box kind of capabilities, so you don't need to install any packages and you can do lots of cool plotting. I've got a very out-of-date plot here, but R is becoming more popular. And really R, as I said, is so popular because, can I follow that link? Is it going to take me there? Because of CRAN, which is this repository of packages which people have written and we can now get use of, make use of. And these all extend the basic functionality of R while maintaining this high quality documentation. Particularly great for us is Robert Gentleman, who was one of the founders, is a strong biologist. That is his background. So he was in Genentech and now 23andMe, I think somewhere else now. But he started a new project called Bioconductor, and Bioconductor specializes on biological data. And what Bioconductor does really well is have tutorials, workflows, so it goes beyond the basic documentation. So, Bioconductor has taken off and now has in itself, I say hundreds, now it's thousands. As a team, we contribute to Bioconductor and we write packages. It's a really nice community. So how do we get R? So who here actually has R installed on their computer? Great. Okay, so this bit is typically kind of tricky as a class. Okay, so we're not really going to have time for you to download it as I'm speaking and me to support you. we would need David in the class to do this. So I'm going to show you where to go. I'm going to show you RStudio, and then in the gap, once I finish this first session, I will, if anyone's stuck, anyone needs help setting up, I will come over and I'll help you. So we're going to install, or we would want to install two things. One is R itself. This is the programming language. And the other one is RStudio. So RStudio isn't the programming language. It is the environment. It is called an integrated developer environment. It is in what R will sit, and it just helps us manage our R kind of session. So the first thing to do is we'll go to the R website. Like I said, it's cross-platform. Oh, everyone's coming. Sorry, I guess they must have sent out the wrong Zoom. So we have R for Linux here. I download R for Mac OS, but we've also got Windows. And just go in there and download this official version. So I think it's now 4.2, the official release on R. For and that should just be straightforward, shouldn't be any problems, but if you do, let me know. The next thing is RStudio, and I'll go to the RStudio site here. I think I have a link to the direct thing. RStudio is a company, right? So they're not free necessarily, totally open source, but they do have free versions of their tool sets. And we're going to get this free version, RStudio Desktop. If I click that, it will go somewhere here, download. Eventually, I can download this. So this is a free version, and you will give you, or it will show you what you will get out of the professional version. Typically, it's support, right? So if you really want to do high throughput computing, that's when you would buy this kind of desktop or even the Studio Serve. Get the support for that. So if you are interested in doing like really big computing, the professional version, you don't need it. I'd have never bought a professional version of RStudio in my life. But if you wanted to, the HPC, so the Jason's team at Rockefeller, they have a license and they have it. But we just need to download that free version and get that on our computer. So then once we have RStudio, it's going to look a little like this. And let me just find my session. Okay. So I've got well, I'll do this in a file project. I'm just going to create an empty project so I can show you. So once you open RStudio, it will look a lot like this. Here is actually R. So this is the R component here in this. It's usually in the bottom left. I don't have an open panel here. This is R. And I can already do R things without knowing anything about R. It treats it like a calculator. Just evaluate simple things for me. On this top right, we have panels. I'm not sure how I described it, but this is the environment. So it's what we already loaded into R. But really useful, and the one I usually keep open, is history, because history tracks what you have been typing. And if you aren't, for whatever reason, recording it in a bit of text file, you can come here, and I can actually send that back to the console. This is the R console here. And we run commands. So that's probably the most useful thing here. This bottom right is more your file window. So this tells me I'm on my home desktop. I've just made this directory, and these are all the files in there. So I can use this as a simple kind of file system, move up and down. It also has my plots. So when we start making plots in our next session, they'll pop up here, and we can see that. We have packages. So these are all the packages. I'm telling you, there are thousands of packages. You can see I've probably installed a few hundred. We don't really need to use this yet, but I can just demo. If I want to unload a package, I can try clicking that. It's going to tell me off and say, that's your base package. You can't unload that. And then we have here a viewer. So when we start making HTML pages, which we'll do in our 5th session, we'll start making nice HTML reports. They're going to appear there, and we can export them to the web browser. And like I was saying, R has help built in, really good documentation, and we can pull up the help in this kind of bottom right panel. So I'm going to show you this in action as we move along. One thing I haven't showed you there is we should have a top left panel. So if I go File, New File, RScript, this is my kind of, I guess, file window. This is where I would do my typing and actually create a file I want to save. So I'll start with, say, 4+1. And I'm going to save this. Okay. Got it there, and now it's popped up here in my file panel. So if I'm typing stuff up here and I want to run these, so if I want to run the line here, I can copy and paste it. So it's going to be a lot of me moving this around the window. I can copy and paste it into here. And it will run more easily as I would just select the line here and select. So then when I've got a lot of things I want to run, I can just select the relevant lines. What else do we need to know about this? I guess one thing which is useful, we won't really use it ourselves, but anyone who, say, learns a bit of Python or knows a bit about terminal, it's quite nice is that R also has a terminal. So this is your command line interface to your operating system behind it. But no, we don't need to use that today. RStudio is definitely winning the war, if there is a war, on being one of the best frameworks for working in R. I can tell you they're also putting a lot of effort into try and support Python inside here. So it's worth getting to know this IDE. Every time I teach this class, someone tells me something new about this IDE. There's like a shortcut, a combination of command strokes does something cool. If you discover one, please feel free to share it with the class. I'm always excited, and I will share them with you as I go along. Okay. So that's RStudio. So this session today is going to be, slower than usual. So we're just going to step through it easily for ourselves. And one of the first things we're going to cover is the different types of data in R. How do we handle lengths of numbers, lengths of strings? How do we handle tables in R, all built in? We're going to try and cover that in these first sessions. First off, as I showed you, R at its most basic is a simple calculator, a graphical calculator. I say that, I'm not sure if graphical calculators actually exist anymore. Do they? They do? So you can do things like arithmetic operations, 3 + 1, 2 × 2, and you can apply, like on your calculator, functions. We'll have a function here, a parameter, you give it an option, and then I can do something with this. Okay. So the first useful thing, really, apart from the arithmetic operation there, is to think we actually have these functions in R. And these are all, the ones I'm showing you here are all built into R. When I tried to unload that base package, it told me off, it said it's built in, you can't take it out. We don't need to do anything to get access to them, but we have these functions available to us. And this square root function is probably one of the simplest. All functions follow this same kind of setup. We have the name to be square root, sqrt. We have parentheses, so we have a start here, the end there, and within this parentheses, following the argument name, sorry, the function name, we will have the arguments. So these are options to give to our functions. Square root is obviously a very simple one. It's not a complex function. It's just going to take one argument, and that argument is going to be the number we want to take the square root of. Okay, so it's a good place to start. And square root 25 obviously gives me 5. Other functions can take multiple arguments. Multiple arguments, if we're going to provide them, are separated by a comma. So in this case, I've chosen some really simple ones. We have min, sum, and max. So min, I just give it as many numbers as I want to get the minimum of. And I just need to separate them by a comma. So here I have 2, 4, and 6. That gives me 2. Sum, just give it separated by comma, and max the same again. These are straightforward, multiple arguments separated by comma. R has many useful built-in functions. I don't even know why I have this link here. I mean, it's thousands, and this is only 40 or so on this, but it's thousands of functions. Don't reinvent the wheel. Just check Google. Someone else already done it for you. As I said, if we want additional functionality, we can load sets of functions into R using libraries, and I'm going to show you that at the end of the sessions for this particular session. But with any of these functions we load in, I was saying it should have great documentation. And we can actually review this documentation very simply from within our R session, just by doing question mark and then the name of the function we want to. And this is really something I do every time I'm working in R. And it's something I really recommend you do as well. If you ever get lost and I'm showing you a function name, just question mark, type it. So we can do that. For this one, I'll do question mark square root. And then in my right side here, it's opened up a panel of help. And I can see it's actually describing two functions. It's describing absolute and square root. And every single function, this is the nice thing about R, they'll always be written this way. You'll always have a description, free text. You'll have the usage. So this tells you how many arguments it takes, right? And what the argument names are. Here we have one argument for both of these called X. This describes what the argument is. It's a numeric. Sometimes this wording can be more complex than it needs to be, but it's saying here numeric. So it's a number. Gives you a little details, and sometimes it like describes, there are different ways of doing square roots, I don't think so. But it will describe, if it makes a choice, it will describe the mathematics behind it. It will provide a reference for where you get the maths from, which is more useful when you're using obscure functions. You want to get the actual paper reference. But hands down, the most useful thing about R, Bioconductor, all these packages, is they give you an example, a working example. And these examples can't not work. Right? So we know if I take this and copy and paste it into my session, and again, we don't understand the R of it yet, but I know it's going to work. Okay, and that's really cool. And it's the way that R libraries are built. They are tested every time they are changed. It's a really nice feature. In this case, all I cared about was the numeric. I knew this wanted a number, and that was the only argument. Okay. The function can, though, get more complex, clearly, and they will often have multiple arguments, and these arguments will have names and order. Okay, so they have an order that they want the arguments to be provided, and they will have a name to say this argument is called this. Okay, so that didn't matter for min, right? Because min just takes numbers separated by commas, and whatever the minimum out of all these numbers, it's going to return it. A really useful function, and I'm going to do this throughout the course. I deliberately choose functions to show you because we're going to use them later. Okay? A really useful function is dir. This is going to tell us what is in the present directory, or what is in a directory. But if I want to know about dir, this new function, I can do question mark dir and look at the description. These functions provide a character vector. So vector is what we're going to learn next, but a character, so strings, of the names of files or directories in the name directory. So it's like listing the files in a directory. We can do that from inside. Gives me all the arguments I need here, but we can see that these arguments are more complex. Path, pattern, all files, etc. And it will give me again an example of it. I think I've just got another slide on this. So, once you start using R more frequently, you're going to have a few functions which you use all the time. You will know the order, you will know the names, so you won't have to go to the help page. What I really want to show you here is that when you do want to update or change an argument, so in this case, I want to say, I want to run this directory function, but I want to ask for full names equals true, full names equals T here. I just need to specify the name of the argument, and then I can tell it what the option is. Okay, so maybe it accepts a numeric, maybe it accepts a character. but I just name the argument, and that saves me naming this argument, having to write out every single argument in the function. So just to go to the help again, full names, this is a logical value, so it's going to be a true or a false. And if it's true, the directory is appended to the file names, and if it's false, the file names are actually returned. So it's just the file names. So let's have a look at that in action. If I just do dir, it's going to list the two files I have in my present directory. It's not very interesting here, but if I do dir full.names equals true, it's going to give me this /, because that's kind of the path to those files. This is more useful, though, if I want to look in my downloads directory. My downloads directory is a mess, so forgive me. So you can see it's just giving me file names. That might be useful. I might just want to know the file names. If I want to read that file, though, I need to know the full path. So then I will do full names equal true. I should give this a thing. I think this is path. And then this will give me the actual path to the downloads folder. The important thing is if I want to take advantage of extra options in my functions, I can just go in the help and look up the argument name I want to change. That's not as complex as we'll get with functions for a long time. So let's get started with how we can hold data in R. So I think I'm just going to do variables and vectors, and then we're going to have a break while I give you some exercises. Make sure that we've got everyone in Zoom. So as with other programming languages, I did call this a statistical language or a scripting language, but as with all programming language and even graphical calculators, we can make use of variables in R. We can store a value as a letter or a word, and it needs to be a letter or a word. Can't start with a number, so you can't have a variable called 1a. It needs to start with a letter or a word. So we can assign values to that. So in R, we make use of this special operator, and it's very much like a pointer, this value here. So if I want to create a variable called x, I just do x, I do this assignment, and I do 10. Okay. So I want to show you that now. I'm going to try and avoid bouncing back between R and the things, but I do want to show you just that bit. So I've got my script up the top. I'm going to do x equals 10. I then go run. I should now have x in memory. If I just press enter, it's going to display with the value of x. Okay. So at this point, and this is just tradition, it's not quite tradition, but there are reasons, but at this point, it doesn't make any difference if we do x like this or x equals 10. Okay. For anyone doing programming languages, this is confusing. So if I do that, it's still going to be 10. In R, I would always advise you when you're assigning, you use this. So then we have our variable 10. Once we've assigned something to x, it's not stayed forever, it's not immutable. I can update x. So again, if you learn Python tuples and stuff, they're immutable. Here I can update x and I can just assign it to be 20 if I have a new result. Now x is 20. And I can use that value x as if it was 20. Right? I don't need to worry about writing it out or anything. I can just use x as the value it contains. So in this case, if I do x plus square root 25, I'm going to do 20 plus 5, and it gives me the result. Okay, so x is just temporarily holding the value, and I can then use it in my scripts. And then I can start to string these together. If I want to create a new variable based on the result of this variable plus square root 25, I've now got y, and y contains that value. Should be kind of straightforward that. Let me know. Assign the value to x, and then I can use that value to create new values. Cool. So then that brings us to our first type of data. And the most simple type of data we can have, most basic data type, is something called a vector. And a vector is a collection of values, but importantly, it's a collection of values with order to those values. Coming from Python, it's not like a set. It is an ordered collection of values. So x and y, we've already created. So we did this just here. We had an x and we had a y. These are vectors. And they are, in fact, just vectors of length 1. So they hold the value 20. And I can now apply another function, length. I give it my newly created vector, and it tells me the length, how many elements, how much, how big is that collection. And here it's just telling me it's vector, which we can see it's just got one value. If I want to create multiple vectors myself, and often we're going to be reading in vectors from files, but in this case, if I want to create a vector, I can do that very easily using another function called combine. So it's C, but it stands for combine. And if I want to create a vector x, which contains all the values 1 to 10, one way I can do this is by doing combine, open my function parentheses, and then I do every value I want to add to my vector separated by comma. Okay, so that gives me x now, and it contains the values 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And if I give it a length, or if I apply it to the length function, length and give it x, it tells me now I have a length of 10. So this is our first multiple vector. And we've added using combine, we've created it ourselves, we can print it out, and we can look at it. There are shortcuts to do this, and Python has them too, most programming languages do. You know, this is a nice example. We just go 6 to 10, but you can imagine if I wanted to go 6 to 10,000, I don't want to write out a long C, 1 to 10,000 or 6 to 10,000. I can use some shorthand, and a really useful bit of shorthand is this. I just do the number I want to start with, the number I want to end with, and I put on a colon, and it creates a vector for me, y, 6, 7, 8, 9, 10. Okay. If you start writing your own software and own R packages, they're not going to want you to do it like this. They want you to write it out more explicitly. And we have two functions which allow us to do a little bit more. We have seek and rep. Seek allows us to go from one number to a final number by steps of here 2. So it goes 1, 3, 5. So that's a vector of length 3. And rep, I should have put the argument names here, is going to repeat this first vector, 1, 5, 10, and it's going to repeat it 3 times. Rep, repeat. Again, if you ever get lost on functions as I'm going along, question mark, and the functions, gets me out of so much trouble doing that. Okay, so these are how we can create structures of numbers. Obviously, what we want to do with these vectors really is we want to be able to extract particular values from them. And I said that they're ordered, and that's important for this slide because we can use something called indexing, where if we want, we can take the 5th or the 6th or the 5th to the 10th value from our vector. Okay, so I create a vector here, 2 to 20, sorry, 2 to 20 by 2. And you can see it goes up 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. It's probably that's 10 then, right? If I want to just pull out the first value in that vector, all I have to do is using these new types of brackets, square brackets now, I give it my vector, I do square brackets, and inside there, I put the number of the positions I want to take. And this is why I ask people if you do Python. If you haven't learned a programming language, this is fine. If you've learned other programming languages, no indexing starts from 0. R, actually, I find more intuitive, to be fair. but the first position is 1. In Python, the first position is 0. Here it's 1. Okay, so if I take the first position, it should be 2. And it was. If I take the 8th position, 2, 5, 6, 7, 8, 16. Okay, so we can access these particular positions within our vector. We can also extract 2 positions if we want to, so it doesn't just need to be 1. And to do that, I can actually use another vector. So here I'm going to create a vector 1, 6 using our combine function. And I can use that then to take out the 1st and 6th position from our Z, which will be 1, 2, 3, 4, 2, and 12. If I want to take all the positions from my vector apart from a particular position, so I want everything apart from here, the 5th position, I will take Z and I'll do -5, and then it's going to remove the 5th position. So this is only now 9 long, and I'm missing 10. So we index with square brackets, and we can provide single numbers or stretches of numbers as a vector to allow us to pull out parts from our original vector. We can then also use this with our assignment. So if I just want to change the 5th position in my vector, I just do Z5, that pulls out the 5th position, and here I can assign a new value to it. So I'm going to do the assignment, and I'll assign 1000. And now if I look across my thing, 2, 4, 6, 8, 1000. And we can also use other vectors in terms of ones we've saved. So here, if I save up front y as 6, 7, 8, 9, 10, I can use that to index z. So it's going to give me these positions in z, and I can assign to that a 0. So now I can start to get quite complex. I can have preset my indexes in y, and I can use that then to set positions I'm interested in z to assign a new position. So here, 6, 7, 8, 9, 10. They're all now 0, and 5 is 1000. So 7. Just a reminder, square brackets for indexing, parentheses we'll use at this point in time for functions. We'll have other things we'll come across. Okay. So as I was saying, R is really good for like statistical mathematical. So we can do really easily arithmetic operations on our vectors in the same way that we were doing just single variables over. So if I want to, I can take a vector of 1 to 10 here, x 1 to 10, and I can do x times by 2, and this will give me now times every value in my x, 2, so that becomes 4, 2, sorry, that becomes 4, 6, 8, 10, 12, 14, 16, 17. So in this way, it's very easy for us to apply an operation across a whole vector. And actually, it's quite fast in R as well. We can also use multiple vectors. So if I've created this new vector y, and this is x, I can also just add vectors together. So I can add x to y, and it's going to do it in a pairwise manner. So we'll add the first element of x to the first element of y. So 1 plus 2 will be 3. 2 plus 4 will be 6. 3 plus 6 will be 9. So we can do arithmetic operations on these vectors. It's a little complex now when we start to have vectors of unequal length. So in this case, y and x are the same length. If I add them together, it's really easy to kind of, well, once we know that they're going to do it pairwise, it's kind of easy to work out what's going to happen. What happens if y is shorter? In this case, it's just 2. Or I just want to add a vector of length 2 here. What it does then is actually recycles. So it's going to do 1 plus 1 is 2. 2 plus 2 is 4. 3 plus 1 is 4. 4 plus 2 is 6. So it's going to recycle the second one, the shorter one. If I make it hard for it by giving it 3, and it's not going to fit into my vector of 10, it's going to give me this warning. Longer object is not a multiple of the sorter object. And it's probably telling me that, you really shouldn't be doing that. Do you really expect a sensible result? What it's done is it's tried to recycle using this, but then it's got to the end and it hasn't got enough to fit in 3 and 10. Okay, in R, if you get a warning, this means the operation is completed and you're going to get a result. If you get an error, it means you haven't got the result. So warnings you need to pay attention to, because you've got a result in front of you, and it's saying, is that really what you expect? In this case, I may want to do this, but it's trying to warn you that maybe that's not what you want. So far we've looked at numeric vectors and variables, right? 1 to 10, 2 to 100 by 2. Vectors can also contain characters or strings. And again, we can just use the combine function. Right? So it doesn't matter if the vector is numeric or string, we can still use combine. And here I'm going to create a string, ICTEM Commonwealth Wolfson. I wrote this a long time ago, and those were the buildings where I used to work. I will change that to Y's, CRC or something. But here we have our vector of length 3, ICTEM Commonwealth Wolfson. If I want to extract the second position, I can do it just like I did in numeric. So I do Y, square brackets, number 2, and it's going to pull out the second position. Really useful thing about character vectors is they can also be used to assign names to other vectors. Okay, so in this case, I can create a vector of 1 to 3. Kind of a weird way I did that, C 1 to 3. And then I can assign to that vector using this names function. So I just do names X, and I give it another vector, here the strings from here. And that gives me back now a named numeric vector. So I have my values 1 to 3, but each one of these values, each index now, doesn't just have a position, it has a name associated to it. So all I've done here is create a vector, and then I've used this argument names X to assign some names to this character string here, this vector, to my numeric. What's really useful about that is now I don't need to worry about positions. I can use the names to start to subset and index my vector. So here, rather than putting 1 and 3, right, to take out the first and the third element, I can actually name it ICTEM and Wolfson, and then I will get back a vector, and it will contain just the values of those I've asked for, right? Just ICTEM and Wolfson. If I asked for something which isn't in my list, so I don't know, or I just make a mistake, and here I ask for whatever reason, a strand, it's actually just going to give me a new variable, a new type of value, and that value is called NA. I'm not sure if I have a. Yeah. So NA is something you'll come across in R a fair bit. Every programming language has a concept of an NA and typically an NAN. And it's because they don't want just an error there. They want to be able to say, not available, we can't do this calculation, or you don't have the information. NA is very different from 0. Right? And NAN is often more problematic. And that's when I've tried to divide a character by 2. I've tried to divide my name by 3. And it gives me a thing saying it's just not a number. NAs are actually handled in R, values allow R to handle missing data quite well. So when we come to later on in the class, I guess I've got a link here to somewhere, we're going to learn how to deal with these times that we get NA values, we have missing data. But in this case, I'm asking for an index or a position in my X which doesn't exist. I've only got names ICTEM Commonwealth Wolfson, and when I do it, it returns me back this not available. It's not available. It's not there in the list. A really useful function for working with character vectors is this unique function. So the unique function allows us to achieve all the unique values in our vector. So here I have gene 1, gene 2, gene 3, gene 4, but I'm going to repeat gene 1 and gene 3. If I just want to know how many or all the unique values in there, I could do unique, gene list, and then it gives me just 1, 2, 3, 4, 5. Okay. So gene 1 and gene 3 occurred twice in this list. So if I want to just reduce it to unique values, I can use unique gene list. If I wanted to get the total number of unique values, I could do length unique gene list. Right? Another really, sorry, just let me see how far we've got before our break. A really useful thing about vectors is we can also use them to store logical values. So I already kind of showed you this when I looked at the directory and I said directory full names equals true. We have logical in R, and it's defined as true, capital, TRUE, or false, FALSE. You can also use shorthand T and F. I can tell you it is better to use true and false as the full thing. It's because there's some problems in R as a self. You can actually overwrite T in R. You can assign your own value to it. You can't overwrite true. But this is a logical where we have the first. This is creating a logical vector here, length 10, I believe. And it will say true, false, true, false. And they get handled in a special way in R. Great thing about logical vectors is we can also use these to index which elements we want to take from a vector. So if I have true, false, this is alternating true and false. If I now provide this logical vector to the index part of my new vector, so I created 1 to 10 here, I do x square brackets, and I provide this logical vector I just created, you can see it only returns the values where it says true. Right, that's good. Often we want to use that in some type of conditional. So we want to evaluate something which will give us true and false. And a really common task in R is to subset one vector of values by another vector. And when we have two character vectors, we can actually use this in operator to say, is values in our A, or whether any values in our vector A matches any values in our vector B. So let's say, in this case, I have gene list and second gene list. If I just want to keep the genes which were in both lists, one way I can do this is to create these two vectors and do gene list in second gene list. And you can see what it does is it just marks in the order here. Gene 1 wasn't in the second list, that's false. Gene 2 wasn't there, so that's false. Gene 3 was in that second list, so that's true. Gene 4 wasn't, gene 5 was. And then gene 1 wasn't, gene 3 is. So it's just telling me which of these elements was in the second list. Once I have this true or false here, I can then use this to subset my first list just to the values which are in the second list. So if I want to check only keep genes which are in this gene list, even if they're repeated, I can then create this logical, do gene list, square brackets because I'm indexing, give it the logical, and it just returns the genes it found in that second list. So it found 1, it found 5, sorry, it found 3, it found 5, and there was a second 3, so that also got captured. Really usefully, though, is to start to do some assessment with arithmetic operations. So we may want to assess, just keep the values which are greater than a certain number, less than a certain number, equal to a certain number. So we can create a vector here, x 1 to 10. And if I want to, I can just use a simple greater than sign here and say x is greater than 5. So which values of x are greater than 5? You can see here it's going to go false, 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 false. and then everything after 5 is true, true, true. This is another logical vector, and I could use that then in a very circular way. I'm just going to go x. Just give me those of x where it's greater than 5. That creates that logical vector. And then that subsets x down to just the values where it's true. Bless you. Bless you again. We can then start to make this kind of complex, right? We can start to combine logical vectors. I want to keep all those above a certain number, but below another number by using these kind of logical operators here. And the most common logical operators are and. So this is, I need both of these to be true. Or, it needs to be either that or that. And reverse. Okay, so this can't be true. So I'm just going to talk you through these now. So let's do x, create a vector 1 to 10. I want all the values where x is greater than 4, except I put this exclamation mark in front of the whole thing. Now it's going to give me all the times where x is, it's the reverse of this, all the times where x is not greater than 4. So I should get true, true, true. So 1, 2, 3. 4 isn't greater than 4, so that's also true. If I want to combine the two together, I want to be greater than 4 and less than 7. So I've got and there. I get false, false, false. And then 5 was greater than 4, less than 7. 6 was, but then 7 wasn't. If I do or, I mean, it's meaningless, this example, but everything is either greater than 4 or less than 7. Okay, so they're all true. And so we can already start to string some of these logical vectors together, and it gives us some power to start to manipulate our vectors. There you go. So again, here we're just creating logical vectors, but again, we can apply then the result of that logical vector to subset our larger vectors. Okay, so if I want to pull out the values from my vector where it's greater than 4 and less than 7, I can just supply that within the index argument. Okay. This will evaluate to the true or false, and then it will pull out the 5th and 6th position. Similar here, I'm going to do a slightly more complex one. It is greater than 4 and less than 7, but I've put the exclamation mark, so it's going to say and not less than 7. So effectively, it's just going to give me those which are not less than 7. And then we get 7, 8, 9, 10. Time for an exercise. So that is actually the time we will take a break. So I'm not sure if I said this at the beginning, perhaps I didn't. So the way this course runs, we'll do an hour at the beginning. We have some exercises, and then I will do another hour class, and then we'll do some exercises. You are welcome to go and walk around, do whatever you want to do now in the break. I do advise you look at the exercises, and I will try and run through the exercises just before my next session. Okay? So you don't need to be here for that, but I recommend if you want to learn and go along, should be. As we move through the course, the exercises get longer. So I will need to have more time to kind of talk through it. So as always, you should have the exercises here. I recommend just having through it, run through it. I'm going to take a quick break, but I'll be back in like 5 minutes. And then I'll be here if you have any questions. If you get lost, and please don't, there's no worry here about looking at the answers. The important thing is getting the solution. We have the solutions always on the next slide. Okay, so it's up to you how much you want to tackle and test yourself, but never feel like you're lost when you can't get the solution. It's on the next slide. I recommend if you really want to go through the exercises, the way I've kind of built it is something like this one here, bonus question. This will be part of the next exercise. Right, so I will use this then in our next exercise and then follow that and follow that. So do look at the solutions because that will help you with the next one if you didn't. It's good timing from Michelle. Okay, so I'm going to leave you to go through this now. We'll start again at 2:30. I'll do an hour session, and then we will do more exercises. And feel free to leave there. You can follow it on Zoom. I am temporarily going to pause the recording. So I have just had a question, which I think is a good question. I haven't really covered it. So, you know, what I did at the beginning is set up a project, and I did this behind the scenes. It isn't really necessary in order to do it. But I want to show you that now. So RStudio has a concept of creating a directory and a project. So if I go new project, don't need to save anything. You can see it gives me some options. New directory, existing directory, it's okay. Version control. So we're going to deal with version control later. And that's super important, but these ones are basically the same. If I do new directory, it's going to give me lots of options. So I think maybe more options than you because I have additional things installed. But what we're always going to do is go new project. Okay. And it's going to say create a directory. So my thing, I'll do my project. It's going to give me some options here, and we're not going to take either of these options. We can explain what these are. The first one there, creating Git repository, is to do with version control. So we have some slides on version control coming up. The second one is actually something we don't cover. But as we move along, effectively this use renv is a way of controlling the versions of the libraries we use. Okay, so in 3 years' time, you might find the package, the library you use is updated. I'm going to show you how you can control this in some ways. But one of the methods is using renv. Renv is a package written by the people who wrote RStudio, which is why it's built in. So ignoring both these, and I'll do create project. Caught up now for whatever reason. I don't know why I'm taking any time to. School, right? I took it out and the whole wall's going to fall down. Actually, it doesn't do much more than allow you to go open project, and it will take you to that location, and it will open that kind of whole RStudio structure as you left it, which is actually useful, right? Because sometimes you just want to close your computer, you want to come back, what to do, and let me just let these people in. Or did they enter? Okay. So what it does is it's going to create this project file, and in there it is continually saving. So it's really just that little bit beyond, like just saving scripts. It's going to keep, and if I start opening scripts here, let's do recent files. Please, my computer's gone really slow. This is worrying. It's doing something in the background. Okay. You know, once I save scripts here, let's save this something. It's just going to know those are the scripts I had open. That's the data I had loaded. So actually, I recommend when you're starting a new piece of work, start a new project, effectively just build a directory, and then just save all your files in there. So I tend to have a new project for every piece of work I'm on. I'm going to pause this and